Yeah, so come back to the talk, advertising. So I worked for two advertising companies. One is Twitter and one is Reddit. So there are lots of interesting things, intelligent things, interesting things I experienced from those experience. I also want to use this as one example for multi-sided marketplace and share that with the audience here. And last but not least, when talking about both ride sharing and advertising business, um, experimentation is something I just selected today to talk more, and this might be of interest to the audience because I saw there are many data scientists um, in the audience, in particular from pharmaceutical company, and you will soon see what's the difference between running like experiment in those non-pharmaceutical applications versus pharmaceutical applications, and of course the latter will require a lot more like rigor. When it comes to medicine or medical test. Last but not least, we're gonna have Q&A session. But as I shared with Guoliang early on, I encourage all of you to share questions along the way. Feel free to raise your hand or just call out, stop me. I think that is a lot more efficient for us to address the questions from the audience along the way instead of waiting until the end. Um, all right. With that in mind, let's move on. Yeah, a quick intro of myself and uh, or with more details. And I graduated from UNC like many years ago, 2017, 2018. And my major was in statistics and operations research. And my research was actually more focused on finance. I was working with professors from both UNC and the Duke Economics department. And I was looking for actually working at finance, being a quant. And I was almost there. Like I did a quant internship as a investment bank called Barclays in New York City, and working on some like time series forecasting. But very luckily, and I got the opportunity like after my internship at Uber, and I accepted the full-time job, full-time offer there, and joined Uber like 6 months later. After defending my thesis, and I joined Uber as a data scientist. Now they call it applied scientist, and I've been working on problem space like marketplace forecasting, like pricing, with some particular applications from causal inference work. And yeah, so I joined Uber before the IPO, and after IPO, there are lots of like rounds of layoffs. I was not impacted, but my team was impacted. Then I say, okay, maybe I can look outward and see if there's any other opportunities out there. And after shopping around in Bay Area, in Silicon Valley, like I decided to join Twitter. I joined as an IC and joined their ads marketplace team. I'll be talking about what marketplace means later on very soon. But basically, my work was around like auction design, pricing, bidding, pacing, like ad load, supply optimization, and for the people who have background in economics. So auction may not be something that's new to you. You may have been suffering from like your qualified exams for auction theory. And at Twitter, I grow from an IC role to like staff IC role, tech lead role, and then eventually become a machine learning engineering manager, leading that team. And what might be more interesting slash funny is that I spent 3 years at Twitter, and I experienced that very chaotic time after Elon Musk acquisition, and I was there for 3 more months working under Elon Musk. That's lots of interesting experience to share. We may talk about later on in this talk, and yeah, and later on, basically like 95% of the organization was cut by Elon, and we all like look outward and find new opportunities, and eventually I ended up with Reddit. And I joined as a senior data science manager, and later on become a senior machine learning engineering manager. And I've been working on like many more areas under advertising business, from measurement to retrieval, prediction, conversion problem, conversion modeling, marketplace quality, auction, etc. So basically, you can see that um, uh, in short, my professional career is basically focused on this marketplace optimization, uh, regardless what type of marketplace that is, from ride sharing to advertising. And I think I would like to be in this area for the next maybe decade, simply because like this area is very impact driven, very optimization focused and data rich. And no matter it's from Uber or advertising, it's you have to optimize like end-to-end delivery funnel. And you want to optimize for end user and driver rider experience. You want to optimize for advertisers and users. And there are like many layers of the problem you want to look into, and there are you need to look into the data. You need to get to the bottom of the data and see what's going on. So all this like real time, large scale like impact data that has been motivating me and drives me moving forward, like to continue working on this area. And you are gonna see that in the next a couple of slides. With that, let's move on. I want to put some context here. So, what do I mean by multi-sided marketplace? And what are we doing with with those types of marketplace? So I would say even if most of us are not working on those marketplace problems, they are actually very typical, and they are very common in our daily life, from day to day. And here I'm using a couple of examples. I saw someone in the audience from e-commerce. Yeah, so Amazon is a marketplace, a very big marketplace, and you have sellers, you have consumers, who want to buy stuff. They create the demand side of the problem space, and you have sellers who are supply the merchandise, like all the items they want to sell. So this is a marketplace. And finance, we have audience from finance as well. That is also a marketplace. You have sell side, you have buy side, and you have market maker, and they want to like drive the efficiency for the marketplace. And like ride sharing, like a decade ago, like Uber started to prosper in tech companies, representing a new like business model, like gig company. And after that, it's not only like just ride sharing, but also like food delivery represented by Uber Eats or DoorDash, and then grocery delivery, Instacart, as well as like company like Uber and DoorDash, they are expanding their business to those areas. So this is also a marketplace problem space. You have drivers, you have riders you want to optimize for, and you want to drive the efficiency across the whole marketplace. And then the last one example I'm using here is advertising business. And actually all those famous names, like social media companies, you are using or not, they are generating revenue to provide the free access to their product. Meta, Snapchat, Pinterest, Twitter, TikTok, even Google. So all those companies, like they maintain a very large organization to run their ads business and to generate revenue. And in this marketplace, the participants are advertisers and consumers. Advertisers have the demand to advertise on this platform, and you have your users to supply their impressions, their time on site, to really consume the ads business, to consume the ads content and engage with ads content, and maybe eventually purchase something from seeing those ads. And so, regardless of which particular marketplace you are looking at, the goal for those platforms, they are always trying to drive in long-term revenue. And I'll be explaining like in more detail what long-term revenue mean later. But of course, now I'm talking about long-term. So that's in contrast with saying short-term. And and the major distinction here is like what's the difference between saying like you want to make long-term money versus short-term money. Um, and uh, Pretty simple is that in those multi-sided marketplace, you have different participants, riders, drivers, advertisers, consumers. You do want to make sure that they can get long-term benefit from your platform, and you don't want to just exhaust um, other short-term interest from your marketplace participants, so that you may lose like long-term benefits, long-term revenue from those users. Maybe one quick example for you to understand this concept is that suppose you are using like Twitter or Facebook, and it's going to be very easy for them to adding like more and more advertising content in their home feed. And by adding more and more ad load or ads content in their main feed page, that can of course generate more like engagement between users and the platform, and that can generate more revenue in the shorter term. That may be cater to like quarterly earnings that satisfy like Wall Street requirement and drive up stock price. However, that can easily make users lose interest, and people like us when using this product can be easily um, pissed off, like feeling the product is becoming less and less engaging, and eventually like not coming back to the platform anymore. So all this kind of decrease in the usage that can hurt the user trust, and that would hurt the long-term revenue. And uh, so I hope by providing this quick example that can give can shed some light on like what the difference between short-term and long-term mean. And then as someone who are like data science like uh, so in this audience room, and I believe most of you like are doing like data-driven work, then you should question how should we measure those long-term versus short-term revenue, and that's actually comes down to all of those experimentation framework, causal inference work, and we'll be shed some light on how tech companies they are using causal inference, they are using experimentation to measure, to quantify those long-term impacts very soon. Again, here I'm just reiterating, I personally very much like those problem space because it's business impactful. Um, they are related to money, to revenue. So yeah, you would get a lot of like spotlights from the company leadership, from executives, and they are technically challenging because they are business impactful. People care about it. Your CEO, your CFO, and the COO pay attention to it. And you want to people like to invest in it, and you really want to improve your not very high conversion rate, and that's very technically challenge because you have millions of users who are using Uber and Meta and Twitter every day, every minute. And how can you apply the scalability in those marketplace optimization? And also those marketplace dynamics, they are always changing. The dynamics between um, riders and drivers and advertisers and consumers, they change every minute, every second. And how can you manage this very big like marketplace properly? So those are really what like drives me, fascinates me for a long time. And I hope I can share this kind of excitement with all of you today in the next maybe 30 minutes. All right, so this is actually one I would say um, meaty slide for today's talk. And we can talk about ads. We can talk about ride sharing business for days and nights. And there are many different problem space under the hood. And that's why like those companies, they are willing to spend like so much time, so much money to maintain like very large organizations, for example, to work on this problem space. And here I'm just trying to give a few examples, a few components in those problem space, like forecasting, matching, pricing, experimentation, control feedback loop, long-term impact, as I just talked about before. Um, and what are the typical like particular problems those problem space should address in ads business, in registration business, and what are the disciplines, technical areas that are involved. And uh, for example, like Meta, like they maintain like 8,000 engineer organizations like to work on like CTR predictions, DVR prediction. It's a very large area, and all they're doing is trying to like push the front of machine learning modeling and trying to provide like as accurate CTR prediction, DVR prediction as possible, and those areas involves like machine learning, deep learning, like even other techniques you have been maybe looking into from GenAI and to reuse all these technical foundations, their attention models, sequence models, to make the predictions more accurate. And in different areas, demand and supply forecasting, like econometrics and statistics, sometimes as some like traditional um, techniques, they are also being used when appropriate. So developing a good standing in those domains maybe can help you find a job in this area. And matching is another example. Like besides, so after you make the prediction, after you make the forecasting, how are you going to decide, for example, in advertising business, like which ads to show to which users? And that boils down to like how are you going to rank ads? And besides the click-through rate and the conversion rate, CTR and CVR, what other like quality components you want to take into account when deciding the final and the ranking result, and to finish this matching stage. And and this matching can be even more expressive or physical when it comes to registering business. Like you may have tens of thousands like riders and drivers that are on road right now, like in San Francisco, different areas across all the streets. How are you going to decide which riders and which drivers to match to each other? And if you are in Research Triangle and you are requesting a Uber trip from UNC campus, are you going to get a car like from Durham? That may not be most efficient way to do. So so that's why you have like multiple teams working on developing like matching algorithm to provide to make this optimization problem like more efficient. And similarly, like after matching is done, how are you going to price? Uh, how how the how is the price you pay Uber whenever finishing your trip calculated? And what are the components there? And how are those components being nailed down and calculated in real time? And when advertisers advertising on Meta, and when my user click on their Nike ads and purchase and made a purchase, how are those platforms um, charge advertisers? And those very important. Those directly impact their revenue. And there are lots of like principles, techniques that can be used. Here I'm using example that are not that should not strange to any of those who have economics background, like generalized second pricing or VCG pricing. And that's why here in the disciplines I'm writing, okay, to finish uh, those matching stage and pricing stage properly. There are lots of disciplines and areas that are being involved: operations research, operations management, optimization, economics, and marketplace design. And that's why for those companies like Amazon, they have a title called economist. And at Uber, at advertising business, they also hire economists to help their like design their marketplace problem space to make sure like these marketplaces are designed in a way that's optimizing for long-term revenue and ensure all the participants they can behave in the most incentive competitive way. Incentive competitive way. Um, Next one, experimentation. And without going to the details here, and those companies they do user split. They do user level randomization. They do user budget randomization. Why budget comes into place here? Because for any advertisers, they advertising on any platform, they always have a budget there, and this actually typically dictated by their marketing budget from quarter to quarter. So the question for different platform is, for example, if I'm Meta and I'm the sales team leader, I'm gonna ask the question every quarter, how can I ensure those big advertisers they can continue to spend their budget on my platform? And how can I convince my customers, those big advertisers, they can not only maintain their budget quota, but also increase their budget quota over time to keep spending on my platform. What kind of data should I provide to my customers? And what should I learn from my backend machine learning teams to really understand the improvement from our platform? So no matter whether you are the sales leader who are talking to customers, or you are backend and engineers, data scientists working on the product improvement, you would all want to use experimentation to justify your launch proposal and see what kind of trade-off decisions you need to make. And um, let me put a statement here or claim here. It would be a lot easier for um, online social media companies to run those A/B testing experimentation than registering business because in registering business, people are being moved around physically, and there are lots of like other constraint in your causal inference 101 class may tell you cannibalization, network effect that's gonna happen in real life. And that's why in those registration business, we have to resort to some different causal inference techniques, switchback, synthetic control, to really help measure the causal impact from your launch proposal, from your ideas. And you would need a lot of like domain knowledge in statistics and econometrics to help you. And the last the last two line items here I put here are about control feedback loop and long-term impact. Um, like in ads, you have bidding and pacing. In registering business, it may not be new to you to get some promotion, like 50%, 40%, um, either as rider or as driver. I don't know if any of you have been like driving Uber or Lyft at all. Whether or not you are a rider or drivers, you would get some promotion. And how are those promotion determined? And whether should I get like three 40% off this week compared to another users who only get 15% off. So there's always a feedback loop here. And depending on the frequency of this feedback loop, whether you are doing in real time, you are doing like in medium frequency or higher frequency or lower frequency, like a monthly, different techniques could be used. Here, I'm talking about operations research, deep learning, reinforcement learning, or econometrics. If we are looking at causal machine learning or causal impact. So this control feedback loop area provides a problem space, a very impactful problem space for people to explore um, if you have the background in those areas. Last but not least, long-term impact. If you are from business school, LTV, the concept of LTV should not be strange to you, and how to calculate lifetime customer value, how to quantify this. whether or not you are using Poisson distribution, Poisson process, or some fancy deep learning model, a deep neural network to forecast user level LTV. That's all applicable in our day-to-day business, depending on the context. So TLDR is that LTV calculation is an important thing. This is something from OpenAI to social media to even traditional industry they are working on. And econometrics, statistics, machine learning, they are all the typical techniques being applied here. All right. I could be felt um, just sharing a laundry list when walking through these slides. Again, I understand this is a very heavy slide. Let me pause here a little bit, and I want to see if there's any quick questions, comments from the audience at all. Um, I saw some comments. Okay, quant, how to measure long-term impact. Yeah, I saw this question from John, asking about LTV. Do you have any like particular question you want to ask at all?
John, do you want to just unmute yourself?
It's okay if you are shy.
Yeah, one question I have is,
Yeah.
your looks like there are a lot of terminologies here. So if I want to learn more, I can
Hmm.
just take the term and go to ask Google or some to learn more about it, right?
Hmm.
Because if I'm not in this field, but I want
Hmm.
to learn more.
Uh, can you say it again?
Yeah, for example, CTR. So if I want to learn more about the CTR, it's a term I can go to Google and find its exact meaning and whatever
Yeah,
related
yeah,
to it.
yeah, yeah. So thank you for calling this out, and actually apologies for this, and always keep our audience context in mind. So yeah, uh, so currently, for any jargon or terminologies, I would just encourage you to go to Gemini AI or ChatGPT to ask for it. They always can return like good result. And for the one you are talking about in particular, like CTR, CVR, yeah, they are pretty commonly used in those tech companies. In particular, in search area, in recommendation system, in ads ranking business. And even in Chinese, we have a jargon, a short jargon for it. We call it like 搜广推, like very popular areas in machine learning, very typical application area. And CTR represent click-through rate, and CVR represent like conversion rate. And but even outside recommendation, outside ad ranking. So I would say like conversion rate, this is a very generic term because when you run your business, you always want to like convert your audience. And when you show those like meta like organic content, you want to make sure your users can engage with these contents, maybe comment on it, maybe sum up, sum down, maybe share, reshare, maybe click on it. So all these can be generically defined as conversion. And um, in some other business, you onboard your customers and eventually you want to convert them. So conversion rate is always something you want to report about. So yeah, so that's some of my quick like comments on those
Okay, yeah,
terms.
thank you. Yeah, yeah, because like I'm not in this area, so, so
Yeah,
some
yeah, 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 yeah,
terms
yeah.
are new to me. Yeah, thank you. That
Yeah,
answers.
thanks for asking. Any other questions on this? Yeah, I do want to talk about John's question, how to measure long-term revenue. And that's a very great question. And there to shed some high-level light here, Um, um, so for example, you have so you can run experimentation, you can run A/B testing. That's what typically being used in social media. And you can also run causal inference, we call it observational study. And depends on the business context. You want to define what it means by long term. And sometimes you care about lifetime, sometimes you care about a few years or 6 months. And depending on the time horizon, you would apply maybe different techniques. If it's only like 3 months, you may just run a long enough, like 3 months A/B testing. And in those social media companies, they are affordable to run such experiment. You have like Meta has 2 billion DAU, daily active users every day. And just taking out zero point 0.1 or even 0.01% of users is already like tons of hundreds of thousands of users, and the statistical power is enough. In other cases, you may not be able to run such long-time experiment. You can do causal inference. You can do synthetic control, and as long as the variance is not too large, that can also give you some statistical confident result. And in other areas, for example, people could use like market train models. They define the states of your consumers, and they can calculate the transition probability for those states. And there are always good papers around this area. But I think TLDR I want to share today is long-term revenue is what marketplace optimizers they should care about. And there are lots of literatures, papers, and also lots of internal knowledges talking about these areas. All right, another question from Andrew. How Uber has improved its service since AI became hot in the past few years? In which areas this service has been greatly improved because of AI? Thanks. Good question. Let me ask you one question before I address this. I address yours. When you say AI, what do you mean? Can you unmute yourself and just speak out? Are you talking, for example, are you asking about large language models? Are you asking about machine learning techniques? Are you asking about um, text generation, translation? So what type of AI are you asking about? I can talk about your question like days and night, but I'm just curious, like when you speak about AI, like what do you mean exactly?
So if Andrew is not a unmuting, I will guess he's probably referring to large language models because the past
Mhm.
few years, the large language models is the one that gets very popular.
Yeah. So I think on one hand, um, the LLM techniques. Um, so it depends on the problem space. For example, you have Uber has its customer service. So if I'm the product leader for Uber, and I got to know um, all these kind of LLM applications, the very first thing I would think of is the customer service. And years before, when you have some bad experience with Uber and you'd like to move forward with reporting something, and they're gonna assign you a human agent, and you may debate, argue with each other to close your case out. And later on, they had a conversational team, to develop a chatbot to help pre-filter some typical standard communication. And I wouldn't be surprised, like they are now further improve this chatbot by leveraging ChatGPT or Gemini AI on the business version. And but of course, I would say I have left Uber for a while, and I can only talk about like my thoughts. how Uber may leverage those technologies. And another application, if I were the product lead, I would do is actually for Uber Eats. And for Uber Eats, it's actually provide um, I would say a area for you to show recommendation system, to show recommendation content, and uh, and for recommendation content, you want to improve the engagement rate. You want to improve the conversion rates. The question is, how are you going to combine those creatives, like food images, like the restaurant, like the images provided by restaurants, and and what those dishes represent, and how to better combine those images. And those could be automated by using LLM to provide all different combinations for the service. And yeah, those would be like the two things on my mind. All right. With that, if no more questions, I wanted to move forward to provide um, two examples. Yeah, so let's move forward. And ride sharing. So I want to use ride sharing for example to move forward. And again, I want to make it like interactive. I'm just curious. What would prevent sorry, it's a typo. So what would prevent you from requesting a trip on a given platform?
I guess price.
Yeah, price. That's a very good call. What
Yeah,
else?
availability in my case,
Oh, yeah, that's a good call. Yes. Anything else?
in chat there's safety,
Oh,
response speed.
yeah, that's a good call. Yeah. Um, yeah. So I would say in okay. In this case, from very basic needs from customers, in real time, it's price and ETA. And just now, people talking about availability. You can imagine like availability could be part of these two concepts. If the availability is very low, your price. So in a reasonably good pricing mechanism, your price should be high enough to prevent like more demand from coming. And similar to ETA, ETA represent estimate time to arrival. So basically, when you put in a destination, how much time to wait to get your destination. And again, if availability is low, like your time to arrival should be high. And those are the two like factors that may prevent you from requesting a trip. And how to get it properly um, calculate the price and how to provide a accurate ETA prediction. These are actually very important questions for any ride sharing business. And that is very important to generalize to other business areas like food delivery, grocery delivery, etc. And let's talk about pricing first. And I hope to share some like high-level product thinking here, and after which we can follow through with technologies. And again, so next question, what factors should we consider when doing pricing? Any thoughts? Again, sorry, I cannot see your
No,
comments,
yeah,
and I
sure.
don't want to.
In chat,
Mhm.
there's time of day, distance,
No, yeah, good.
vehicle type,
Okay, we got some smart audience. Good. Uh, Anything else being shared? Oops. Oh,
traffic,
sorry. I may already show the answer. Sorry. Um,
competition,
I I like competition.
fuel pricing.
Fuel pricing. Okay, so maybe I should reshare my screen, right? Um, Sorry, give me a second. I lost track of my tabs,
No
as
problem.
always.
Answers are still coming in from chat. There's another
Oh,
mention of traffic congestion.
yes. All good call. You actually, okay. So maybe with this audience room, we can build a marketplace team for Uber. Um, right. Where's my slide? Okay, I found my slide, and let me reshare my screen. Okay, so here are the dimensions. Um, there are typically four components when it comes to pricing, and by the end of the day, we'll get to like how machine learning, how AI technology may help with those areas, and we should have a base price, and like per mile you drive and per minute you spend, there's always a base price there. And you want to consider like basic features as you shared there, like time of the day, maybe day of the week. And okay, whenever I'm talking about time, I always want to push for a. So imagine you're in interview and you're talking about time. I would always ask you the question, how should we encode time in feature engineering? We can get to that later, and you may answer your questions in the chat. And the location. So how should we encode location? How should we encode your the distance um, in those price calculation and the product type? And that's about product design. The base fare might be different. And what might be more important is search. And I believe all of you have experienced um, like the price change from minute to minute, in particular when it's in rush hours or when you just got down like from airport. And this is actually so surge pricing is a reflection of demand and supply. And how AI could play a role here is you don't want to have your surge pricing lagging behind. You want to apply, you want to leverage surge um, as a adjustment lever ahead of time. So you actually want to predict demand and supply in real time. And the prediction of demand and supply in real time, any prediction problem, you can perhaps turn it into a like AI problem. And or years ago, or many years ago, you're talking about this as a econometric prediction problem. You may have all these like ARMA type of models predict time series. And later on, you have machine technologies. You can build those um, models with a regression type of object function and forecast demand and supply as numbers. And then if you think about the sequence here, like this could be like easily generalized to using sequential models. And the sequential models is now very similar to whatever powers like Gen AI, because you want to predict what's going to happen in the next time unit. So this actually happened in industry, like no company or no particular applications. They started from something very fancy. There's always this like evolvement as time goes by. And maybe what makes a difference here is whether or not you want to build all the things in-house versus you just leverage like your GenAI techniques to help you build a model that may not be operating at a very large scale. And last but not least, promotion, because you always want to subtract the promotion component from your price. How can you check the causal relationship? And as I said before briefly, Uber even published their causal impact, like a causal inference package. The name of the package is causal impact. and they apply all the different kind of causal machine learning techniques, including double machine learning techniques by Chernobyskov. So so all these areas. So what I'm saying is like all those components they can be powered by some type of like AI techniques. And all right. So let me pause here. I know I'm only giving a very high level application areas when deciding pricing and how AI might be leveraged there. Any quick questions about any particular topic here? In the next slide, we're gonna briefly talk about ETA, ETA prediction.
I guess I have a quick question,
Yes, please.
which kind of goes back to your earlier mention of the inclusion of economists in
Mhm.
companies.
Mhm.
So I was wondering how much of innovation or development is happening that's creating new algorithms or doing new research versus improving existing ones.
Um, I'll put it this way. It's the so I would say mostly when you are related to a private sector. So your team is taking some type of KPI or OKR, whatever you call it. So most of the time you are working on applied work.
Hmm.
Um, and you want to apply those techniques to your particular problem product area. So and that's actually how the company grow. So for example, um, uh, when Meta is only Facebook, they only need to forecast or predict like CTR or conversion rate for their Facebook Blue app. Okay, and then they purchase Instagram, they purchase WhatsApp, and then they are building out Threads, which is a replicate of Twitter, and they are building Reels, a video platform, as a replicate, or okay, replicate maybe a too heavy word, as something similar to TikTok. And when you develop those different teams and product, you need to build your machine learning teams, your backend engineering team to really power the service of those products. And you may you may just need to like leverage those existing techniques, but with some like tweaks and improvement in your particular areas. So that's one type of applied research I'm talking about. And this is no easier at all compared to more theoretical or academic research. No easy at all. And so that's why there's always like series of conference like for so even for ICML, for KDD, for NIMPS, in those conference, they would always maintain like sessions for industry application. They are not proving any theorems. They are not trying to improve the conversion rate for central limit theorem by any magnitude of order, but still like they are trying to improve like the efficiency of the system, not only from modeling side, from algorithm side, but also from engineering side, scalability, extensibility, etc. On the other hand, there are some companies big enough to still like working on research and push the boundary. OpenAI could be one of them, but recently a lot of OpenAI people like joined the Meta, and they may no longer like publish their work in the future. And Google, they maintain their Google research team. They are still doing research. They still publish their content. So in general, it's more often those very big companies who have the money to build those research team who will still more focus on like doing like research, pushing the boundary of knowledge. But most of other like product teams, they are still working on application. They are improving existing algorithms, architectures, architectures, model architectures to serve their own business purpose.
Thank you.
Yeah. Any other questions? All right, let's move on. So we can briefly discuss ETA prediction. As I said, whenever you put on a destination in your Uber app, you're gonna see a ETA. You're gonna arrive in 35 minutes, in 30 minutes. This is a big topic, and all those different companies they publish papers on this. And for those of you who have tried to find a job in those companies or who are planning to find a job in those areas. This is also a typical machine learning design problem or design question. And how to forecast ETA. And I'm using this example here because you can argue that this is also a typical applications of machine learning and more generally like AI. And I call it a classic like regression ML problem. Classic in the sense that you want to predict something that is numeric. It's not a classification problem. You want to forecast like the time to arrival, and the model architecture and the process of these problems is very typical. Like you want to do feature engineering, you want to do model selection, you want to do model evaluation, and you want to run experimentation to test out the improvement of your models. And how this relates to AI? Well, first on one hand, like ML is a subset of AI, and on the other hand, as you can see from the paper, I mean the blog I'm referencing here, sequential model is being used. And when it comes to sequential model, you can ask, okay, can we use attention or self-attention mechanism? And that's how things like related to AI. And this may directly this may not be a direct application of ChatGPT, but you are reusing or using the model architect that powers those large language models behind the scene. And those sequential forecasts, they actually plays a role. So I'm putting this thing here as a reference, and feel free to check this out. Are there any comments from? Okay, so
Yeah, quick question, sorry.
yeah.
Estimate time to arrival.
Mhm.
So if you know a location of the rider and the driver, can't you just use the route to calculate that? Why do you need to use machine learning for this problem? I probably missed something.
Yes, very good question. So uh, let me give you okay. Um, you know, yeah, you know the destination. If you know the destination, and if you know the starting point, that's give you some basics of this ETA prediction. However, the traffic is random, and the traffic is random. The weather is unknown. And do we have any particular event? You don't know. So all those context information they are not covered by a simple calculation of like your speed divided by your speed divided by your distance divided by the speed. Does that make sense to you?
Yeah. Okay, so I guess that makes sense.
Yeah, and also time of day, like like rush hours versus non-rush hours. And the more you think about this problem, like the more like features you may think of. And that's actually in all those machine learning like system design question. People like the interviewer will ask you like what kind of features do you want to incorporate? And then you would want to discuss like yeah all the features or signals you want to incorporate that's gonna affect ETA. And uh, and then the question is how do you build a pipeline to empower this system in real time with millions of users using this using this product in real time across all the cities in the globe. But that's a separate and engineering type of question.
Okay, thank you.
Cool. Any other comments, questions?
Just a quick comment to direct people to the reference here. I'm looking at it and it's very helpful because it includes animated
Yeah.
diagrams and the attention mechanism. It's a fascinating uh, read.
Yeah. Yes. So please check this out. And all right. How much time we have? Um, we are scheduled to finish at 7, right?
It's up to you. Like we can take more
Okay,
time
yeah.
if you
I
want.
can I on let me see. Okay, I have four more slides. I can quickly talk about that. Now let's shift from registering to advertising business. Um, Before I joined industry in advertising, I couldn't imagine how complicated this areas is because now later I quickly understand advertising is $1 trillion market. And all those big companies, which you may have lots of stock shares with that, they actually powered by advertising. That's like Google, Meta, um, and all like a mid-sized company in social media. Even Amazon, they have like the sponsor product or sponsor brand like organization where the revenue generated from running ads. So they are the so-called first-party ad platform who who monetize by showing ads to their users. Um, when you Google something like Nike shoes, you may see a lot of like shoe recommendation from Nike related to Nike, and some of them are sponsored by the sellers. Um, and similarly, when you use Meta or Twitter or Pinterest, Snapchat, TikTok, you would also see content with a promoted like tag somewhere on the screen. Like other platform like Amazon, Coupon is an e-commerce platform like being used by Korea and Taiwan. Um, Roblox, like if you have kids, you may have purchased something from within Roblox, and there's also ads there. So this was what we call the first-party ad platform. So they are using their own like user base, we call it inventory base, to show ads. And again, because it's $1 trillion business, and everyone in this business, they're trying to squeeze more edge from their customers. So there are lots of like smaller companies or different departments within first party platform to find opportunities for others. So this is what we call third-party ad platform. That's basically have a demand side platform and a supply side platform. Um, so those are some like bigger contexts. You can understand like the supply or demand side platform in a way that when you log in some smaller websites, you may still see like somewhere on their web page, left or right, above or below, like they are showing ads. And for those smaller websites, they wouldn't be able to maintain a marketing department or hire engineers to maintain how they show ads. So they basically just create those pixels in their website, and they talk to some supply demand side platforms to ask for ads to show on their website. And there are all different kind of companies doing this business, trying to connect those different inventory and advertisers to reach out to more users. And so I wanna spend the rest of the talk very briefly talking about optimization in advertising business, in particular the first ad platform. And in these areas, we have demand side, we have supply side. That makes this advertising a marketplace problem space on a first party platform. And we have demand side, which is advertiser. they have the demand to show ads on the platform. For example, Meta, they have like millions of advertisers who want to advertise on Meta, on Instagram, on Facebook, on Reels, and uh, they want to advertise on Meta because Meta has 2 billion like daily active user, and there are tons of people, tons of time are spent on Meta. And then let me ask the next question: what do advertisers look for when they want to advertise on those platforms? Um, all those advertisers, they spend like millions, even billions of dollars, right? And now they are spending those money with those first-party ad platform. What do you want? What are they looking for? Uh, so here I'm providing a very short, even incomplete picture. So there are different type of advertisers. We have big advertisers, we call them brand, like Coca-Cola or Tesla or Apple or Microsoft. Their marketing department, oh, someone answered like click-through rate. We will get to that very soon. So for those like big brands I just mentioned, they just look for awareness. They are looking for brand awareness. And so they want to reach more, users so that people are aware what they have, what those big advertisers they have, what kind of products offering they are provide, what kind of like new products they are giving, maybe a new style of iPhone, maybe a new type of like Tesla, maybe a new type of whatever things like they are selling, but they want to improve the brand awareness. And then you may ask, okay, so we are spending like millions, billions of dollars to improve brand awareness. How should we measure it? How should we measure the return of investment on this? That's a good question, and that's a very challenging question. That's all these big advertiser, big first party ad platform they are trying to solve. Uh, Um, um, uh, that's how all these kind of like brand lift studies or surveys are being provided, and all those data scientists are hired to do to measure the brand awareness lift. Uh, Next one is performance. So advertisers want to drive performance, like the purchases, people install their apps, people purchase their stuff. And then as a first-party platform optimizer, your question is, how can we drive more performance for those advertisers? How can we decide if I should show Yunxiao a Nike shoes or a or Adidas or Lululemon? So how can we match between the advertisers' ads and the users to drive click-through rate? And then after click-through rate, we come to their website. And how should I optimize for add to cart? And after add to cart, how should I optimize for purchase? So all those different steps, they are a natural part of this whole customer journey. And even if it's as simple as one click for each of us, in aggregate, it's like millions, even billions of clicks or conversions or purchase or add to cart actions for those first party ad platform. And this provides like all the data and the features those machine learning model requires to predict to rank ads properly. And of course, you may leverage those self-attention models to do that as well. And last but not least, imagine you are one big advertiser. You are the marketing manager for from Coca-Cola or Microsoft, and you are doing decision making every day. You are doing decision making like strategically because you are in charge of billions of dollars marketing budget, and you need to decide how much budget to spend on Google, on Meta, on Reddit, and you can easily convert this as a constrained optimization problem, right? Other than that, like besides just looking at the performance and the brand lift, whether or not those first-party ad platform they can provide you a cohesive and convenient experience. That's also very important because you don't want to spend. You may not have enough like human power with you to really spend like 1 day or 7 days with one ad platform and then setting up campaigns. Setting up your ad campaigns. You want to automate this process as much as you can. And this actually become another very hot topic for Gen AI application, how those first-party ad platform can leverage Gen AI to make the onboarding and the retention experience easier for their advertisers. Um, so this is another important aspect for advertiser need. And so this might be, let me see. Okay, this might be one last slide I want to briefly touch on for ads optimization. I call it, we want to improve full funnel efficiency. Um, I'm trying to up level the problem space as much as I can. Basically, if you are a user on Meta, on Instagram, um, as an engineer, I need to decide, I need to design a system to decide which ads to show you at this particular request. Um, and and then on the other hand, for this particular ads, should I show you this ads at all? Or if not, who else should I show this type of ads? And last but not least, like how much ads to show? Should I keep showing the same ad? Should I show like only one or two ads every 10 organic video? Does the advertiser they have enough like budget to spend on those campaigns? So all these are actually important decision points. Um, within that 500 or 600 millisecond. And um, here I'm talking about some component in this journey from ads ranking recommendation, targeting, like ads measurement, ad load decision, budgeting, pacing, and bidding. So in all those companies, typically they have one team each or multiple teams to work on each and every of those problem space and all of them are actually empowered by machine learning to some extent, or you can call it AI to some extent, to really make it more efficient, to make sure for every step across this journey, we can drive more CTR, clicks rate, we can drive more conversion rate. And the more features you can incorporate, and the higher the CTR you can achieve, and you may want to apply more sophisticated like model architectures, like attention models or transformer, to really squeeze out the information from those features. For the sake of time, I don't have time like to really dig into this. But all I'm saying is this is a very deep domain, and AI and machine learning are largely used for those areas. So last but not least, I also want to talk about engineering challenges. Um, uh, if you have been going through like backend engineering system design, those fancy terms should not be that strange to you. Availability, latency, scalability, extensibility. Um, uh, I have been only working at those like mid-sized, like big-sized company, and they always have a high requirement for latency, for scalability, and for um, error tolerance. So if you are looking for opportunities in AI domain, I would argue that it's not only about those fancy models. Um, there are lots of opportunities created in the engineering aspects of those problem space, and whether or not you can build a stable infra to really support the application of AI models or new AI models. How can you build like feature store properly to serve AI models in real time and support all this so-called real-time training or incremental training or um, online learning. So this is also very important areas, and it's actually like no easier at all compared to those model architecture development. So I just want to call this out because I don't want to like understate the criticality of this area, and uh, even for those who may have more like a backend engineering background, rather than like machine learning background, there's also a like place a headroom for you to maximize like your potential in this area. All right. We only have 10 minutes left. Let me pause here. And I hope today I give you a sense of what's like high level the multi-sided marketplace has been about. And with examples from Uber ride sharing and advertising business. I know I have been only scratched the face uh, very softly in the problem space, but my goal here is to provide you with a POV, a very high level POV, like what are those problems about, what are the typical components in those areas, and how machine learning and AI might be applicable to it. And then last but not least, how engineering consideration should be considered and incorporated when making those applications available in real life. All right, let me pause here, open the stage for the audience. Any questions?